That didn't do what I wanted to. Okay, so my name is Holly Edmondson. I'm not going to try and go back to that slide, but I currently am working on an electrolytic capacitance tilt sensor to deal with some of these noise issues that we're going to be having. So I'm going to start first off with some of the noise that is inherent in the things that we're trying to measure. First off, we have built a vacuum chamber, as these two wonderful models are demonstrating. We had this built in order to get rid of any damping that might occur due to the viscosity of air, or to minimize it. Also, the vacuum can get down to 10 to the negative 6 torr, which is what we need around, I think it's well below actually what we need for our sort of measurements. It also will help avoid heat transfer from the pendulum to the attractor plate. Another concern is thermal isolation, as I'm sure you all know. Metals expand and contract as things get hotter or colder. So we have built a thermal isolation unit that is, the vacuum chamber is in a thermal isolation unit that we've built. And inside of that we have another device that actually controls the temperature. The temperature can be controlled to plus or minus 0.1 Kelvin. So it's pretty accurate as far as that goes. We also have our pendulum and suspension system, as I'm sure you've all noticed in life. If you're hanging on to things, they tend to sway back and forth. So in order to avoid that from happening, to lessen the damping, or rather to dampen that, we have this, well, first off, we're using a tungsten fiber, which is incredibly thin. It's 20 micrometers. And also, the cylindrical casing that I'm showing here has a series of magnets in it, which induces an eddy current, which acts as a magnetic damper to help keep the pendulum from swaying. And finally, the electrostatic shield that Nathan mentioned earlier, due to the Casimir effect, we can actually get certain like vacuum and metal Casimir effects like electromagnetic effects. To combat that, we are putting a beryllium copper shield between the pendulum and the attractor plate. Another problem that we have is tilts. Say our building starts leaning, like the Leaning Tower of Pisa, or we are in California, so with our earthquakes, we do have a very rowdy marching band. So we are going to put on top of, well, this is what it would look like in cases of tilt, but I'm making an electrolytic capacitance tilt sensor to measure any tilt that may occur. This is a very rudimentary design. What we have here is, on the red clip is a piece of aluminum, which forms a natural oxide layer. In the solution is sodium bicarbonate in water, so baking soda in water, which acts, so the aluminum acts as one side of a capacitor, and the sodium bicarbonate solution acts as the other side of the capacitor. And the oxide layer that naturally forms is the dielectric between the two. And then you put a current through that, and you, voila, have a capacitor. Testing this capacitor has actually...
The other button.
You can go to
the
one of the buttons gives you the menu, the other one gives you forward.
Just do it manually. So testing this, we have actually found, in the testing that we did, we found at 1 kilohertz rather, and 2.5 volts, we were getting a change in voltage from 0.3 to 2.1 volts, just bringing the piece of aluminum in and out of the sodium bicarbonate solution. The surface area was roughly 100 millimeters squared, and we got a resonance at 760 hertz, which with a little bit of electronics math, we found to be a capacitor of 4.1 microfarads, which is a fairly large capacitance. So then the big question was, okay, so we can get one capacitor to work. What if we put two metal rods in the same solution? Can we get two to work? And the answer is yes. There is a video that shows, Okay, sorry guys. Okay, so this is a video that was working on my advisor's computer, but basically what the video shows is the two rods hanging in the solution, and as the rods are moved up and down, you can see on the oscilloscope that the waves will get smaller, the amplitudes of the waves will get smaller or larger as more is immersed and the other rod is unaffected by that. So it does work. I'll show you the video later if you're really interested. But it was working before. And since the remote control has completely abandoned me now.